Okay, so in this section, we are going to talk about some trig identities and trig equations. That's all of chapter 13. 13.1 is just about the trig identities. So just a quick definition. A trigonometric identity, something that's an identity is something that you know to be true, and it's true no matter what angles you plug in. So a trig identity is an equation involving trig functions that is true whenever the expressions are defined. So rather than saying like they're equations that are always true, because that's not the whole truth, there are certain functions like tangent isn't always defined. Remember, tangent has vertical asymptotes. So the an expression involving tangent would be true as long as tangent's defined. Same thing with secant, cosecant, and cotangent. They all have places where they're not defined. So we have to be kind of more specific with that definition. So here are all of our basic trig identities. We've got 5 different categories here. Some of them are going to be more intuitive than others. The quotient identities. The first quotient identity is this. Tangent of theta is equal to sine over cosine. Okay, so tangent of theta is equal to sine over cosine as long as cosine is not 0. So that kind of goes to that whole whenever expressions are defined thing. Because if cosine was 0, we'd have 0 in the denominator, and that's bad. This is a comma. I just realized that looked like a 1 or something. It was just a really long, bad comma. So kind of a little like proof, almost. Keep in mind that tangent, we defined it in the last chapter to be y over x. And remember, sine was associated with y, and cosine was associated with x. So hopefully this expression makes sense too. And then we know that cotangent is the reciprocal of tangent, so we flip it and we write cosine over sine. Same proof that we have right here. Cotangent, we defined it to be x over y, so hopefully that should make sense. And then comma, whenever sine is not equal to 0, because that would make this expression undefined. Okay, next category would be the reciprocal identities. We basically already know these ones. Okay, so there are 3. First one, cosecant is defined to be the reciprocal of sine, so 1 over sine. Secant is defined to be the reciprocal of cosine. And cotangent is defined to be the reciprocal of tangent. And then for all 3 of these are true as long as the denominators are not equal to 0. So like for this one, sine can't be 0. For this one, cosine can't be 0. And for this one, tangent can't be 0. But other than that, they're defined everywhere else. Okay, so again, those ones, not new. Pythagorean identities. Here is the first Pythagorean identity. Cosine squared plus sine squared equals 1. This one will be super, super important, especially next year in pre-calc. This is a huge one. Cosine squared plus sine squared equals 1. So just a little proof sort of thing for you. Picture yourself on the unit circle. I will give you the unit circle. Here it is. So I have some little triangles drawn in here. Remember, if you're dealing with the right triangle, you've got the whole Pythagorean theorem thing, which is why we call these Pythagorean identities. So if you wanted to do a squared plus b squared equals c squared, you would do x squared plus y squared equals r squared. Okay? X squared plus y squared equals r squared. So x squared plus y squared equals r squared is where that comes from. Now remember, cosine is associated with x, sine is associated with y, and then in the unit circle, the radius is always 1. So that's exactly where this top line comes from. Okay, then we have 2 other Pythagorean identities. For the second one, say that I divided this whole thing through by cosine squared. So cosine squared divided by cosine squared is 1, plus sine squared divided by cosine squared ends up being tangent squared, because remember, sine over cosine is tangent, so if I throw in the squareds, I get tangent squared, equals, and then divide this by cosine squared. 1 over cosine is secant, so 1 over cosine squared is secant squared. That's the second one. Throw a little colons, semicolons in between. And then the third one is if I take this original one and divide through by sine squared. So cosine squared divided by sine squared is cotangent squared. Plus sine squared divided by sine squared reduces down to 1. And 1 over sine squared is cosecant squared. And these are defined all the time because there's no denominator. I guess really whenever any of these are defined. So whenever tangent's defined, whenever secant's defined, etc. Second to last are our co-function identities. So our co-function identities, we have 3 of them. First one is this. Okay, so let's explain exactly what this means. We'll pick a random angle. So let's pick 30, or I guess pi over 6. So remember, pi over 2 is the same as 180. So this works for 180 degrees, or it works for pi over 2. Either way, I think it makes more sense to us to do 180. Okay, so the sine of 180 minus 30, sine of 180 minus 30, that would be 150. Sine of 150, right here, would be 1/2. This says is the same as the cosine of 30, which doesn't feel right. Did I write that down wrong? I'm sorry, not 180. Sorry. Pi over 2 is 90 degrees. Okay, so let's say we choose like theta as 30. Okay, sine of 90 minus 30 would be the sine of 60, and the sine of 60 is root 3 over 2. This identity says it's the same as the cosine of 30, and the cosine of 30 is root 3 over 2. Okay, so if we test these other ones, we also have basically the same one, but you switch. Okay, so we've got that one, or again, instead of pi over 2, you could write the identity in degrees and write it as 90. And then the last one is that the tangent of pi over 2 minus theta is equal to the cotangent. Again, or 90. So you can think of those in 2 different ways, in terms of degrees or in terms of radians. And the last one is the negative angle identities. First one is this. The sine of a negative angle is the same as the negative sine of that angle. So again, you know what? Let's go with 30 again. Sine of negative 30 is negative 1/2, which is the opposite of the sine of 30. Okay, so the sine of negative 30 is the negative version of the sine of 30. Basically just says that these two have opposite signs. Something down here with its reference angle down here. So 315 and 45 have opposite values of sine. 60 and 300 have opposite values of sine. The next one says that the cosine of a negative angle is actually the same as the cosine of that angle. So if we do 30 again, cosine of negative 30 is root 3 over 2, which is the same as the cosine of positive 30. And then tangent is also opposite. Tangent of a negative angle comes out to be the negative version of tangent. So any of these, like while you're taking your final, any of these would be on a note card, so you don't have to have any of them memorized. Some of them you'll use them more and more and you'll end up memorizing them, but you don't have to. Okay, so example 1. A lot of these examples you're basically just going to try to figure out which one makes the most sense and what you would use. So which ones have sine and cosine? Okay, so none of these have both sine and cosine. These ones do, but we would need to know what theta was, and we don't. These ones do. This is going to be the one that we're using, is this one right here. Okay, so cosine squared plus sine squared equals 1. Okay, and we plug in what we know. We know this, that cosine is equal to 1/3. So we take 1/3 and we square it. Okay, so 1/3 squared is 1 over 9. Then we subtract 1/9 from both sides. Okay, so this will cancel. And so 1 is really like 9 over 9. So when we subtract 1/9, we get 8/9. And finally, since this is being squared, we take the square root of both sides. So whenever I square root, remember you're always going to get a plus or minus. The square root of 8 simplifies to 2 root 2, and the square root of 9 is 3. Okay, so it's either plus or minus. To figure out which one it is, you look at that. Our angle is somewhere between 270 and 360. If I am somewhere in this quadrant right here, my value of sine is going to be negative. So the value that I choose is the negative one. Not both, you've got to choose the negative one because they give you a specific quadrant that this angle lives in. Okay, next, very similar type of problem. This time we want to find secant if you're given a value of sine. So you're actually going to do that same cosine squared plus sine squared, but this is going to be a combination of two different identities. Okay, so we're going to take sine squared. So if this is sine, then sine squared, you would just square this thing right here. So negative 2 squared is 4, 7 squared is 49, and then we're going to plug it in. So I'm trying to figure out what cosine is, then I'll use that to figure out what secant is. So sine squared is 4 over 49 equals 1. So I subtract 4 over 49 from both sides. Very beautiful fractions that we're dealing with here. So I get cosine squared equals, and then remember 1 is really like 49 over 49. Okay, so I get 45 over 49. And then to figure out what cosine is, I take the square root of both sides. So I end up with cosine equals, could be plus or minus. I will look at the angle in just a moment to figure out whether it's the positive or negative version. Square root of 45. 45 is 9 times 5, so this is 3 root 5. And then over the square root of 49, which is 7. So two things we need to do. First of all, I am in this quadrant right here, which means it's this one. When I am in that quadrant, cosine is negative. Okay, so I choose the negative version. I always use the quadrant to choose which version. And then secant is the reciprocal of cosine. So I'm going to take this fraction, I'm going to flip it. 7 over negative 3 root 5. But remember, you don't ever leave these rationals in your answer, so multiply by root 5 over root 5. Okay, I can just put the negative up top, that doesn't matter. And then I have 3. Root 5 times root 5 is 5, so 3 times 5 is 15. So that is the lovely answer that I have for that question. Okay, now we are going to simplify some of these expressions just using some of our properties. So basically, a rule of thumb here is that you want to write everything as either sine or cosine. Whenever you can, write everything either in terms of sine or in terms of cosine. So tangent. Tangent squared is sine squared over cosine squared. Okay, so that's the tangent part. Cosecant is the reciprocal of sine. So this is 1 over sine squared, and then minus 1, over secant is the reciprocal of cosine. So then you just throw the squared in there. So that's where we're at so far. These two will cancel. Sine in the numerator, sine in the denominator will cancel. So I have 1 over cosine squared minus 1, and then divided by 1 over cosine squared. Well, if we look at this piece right down here, if you're dividing by a fraction like that, it's the same as taking this whole numerator and multiplying by the reciprocal. Okay? So I'm going to take that whole numerator, this piece that I have right here, and instead of dividing by 1 over cosine squared, I'm going to multiply by just cosine squared, technically over 1. Okay, so when I distribute, I'm going to distribute right here. These cosines will cancel, and all I'll have is 1, and then minus, now distribute it right here, 1 times cosine squared is just cosine squared. Okay, and then last little thing goes back to this Pythagorean identity. If cosine squared plus sine squared equals 1, I could subtract this cosine squared from both sides. So I could have 1 minus cosine squared equals sine squared. Okay, so that means this is equal to sine squared. Okay, so that is as simplified as you can get that expression. All right, so let me show you one thing really quick where this came from, because this will pop up a lot, so I want to make sure you understand this. So if I subtract cosine squared from both sides, I'll have sine squared equals 1 minus cosine squared. So if you ever see a 1 minus cosine squared, you can write it like this. Okay, next, secants, remember, is 1 over cosine, and then you divide that by sine, and then times, here it is again, 1 minus cosine squared, that is the same as sine squared. Okay, so now one of the copies of sine right here can cancel with this copy of sine right here. Okay, so this cancels. Here I'm left with just one single copy. It's like reducing an x squared with an x. Okay, so now I have 1 over cosine, and then times just sine right here. So this is like sine over 1, so I can write this as sine over cosine. And sine over cosine is one of our given identities, that is tangent. Okay, so your final answer would be that that's just equal to tangent. All right, last one. Rewrite this in terms of sine. Okay, so when they say to rewrite something in terms of sine, that means they want every little bit of it to be rewritten in terms of sine. So we're going to start by writing it in terms of sine and cosine, then we'll kind of tweak a little bit. So cotangent is cosine squared over sine squared, and then minus tangent is the reciprocal, that is sine squared over cosine squared. Okay, so as of right now, they do not have a common denominator. Their common denominator would be sine squared times cosine squared. So we can multiply this one by sine squared over sine squared. And we can multiply this one by cosine squared over cosine squared. Okay, so here's where we're at. Cosine squared times cosine squared is cosine to the 4th over our common denominator. And now these denominators are identical, so we can put it all over one denominator. This will be sine to the 4th. Okay, common denominator, cosine squared, sine squared. In the numerator, this actually factors. This is technically the difference of squares. So I can do cosine squared plus sine squared, cosine squared minus sine squared. Okay, and then over my same denominator, haven't changed that yet. Okay, so this is just 1. Cosine squared plus sine squared is just 1. And now I can start to replace things. So if I look back up here, if sine squared is equal to 1 minus cosine squared, that means that cosine squared is equal to 1 minus sine squared. Okay, so just a little flip. So it's also true that cosine squared is equal to 1 minus sine squared. Okay, so every other cosine I have, I'm going to replace it. So this cosine squared, I'm going to write 1 minus sine squared, and then minus that other sine squared. So this 1 minus sine squared, that was this cosine. And then I still have minus sine squared. And then over cosine squared, I'm going to replace it with 1 minus sine squared, and then times sine squared. So finally, let's combine up like terms. There are 2 of these in the numerator, so I can do 1 minus 2 times sine squared. And then in the denominator, I'm going to distribute the sine squared. So sine squared times 1, and then minus sine squared times sine squared. Okay, so it's not pretty, but that is rewriting in terms of sine. It's just like really good practice to see if you can manipulate some of these identities. Okay, so that's it.